Today, we'll break down every major branch of mathematics in the simplest way possible. These branches are divided into three main categories, namely pure mathematics, or theoretical maths, then applied mathematics, or the math in real-world applications, and the third one is, this category doesn't have a name, so we will call it other maths. Let's begin with pure mathematics. Arithmetic. Arithmetic is the simplest and oldest part of math. It's all about numbers and basic operations, addition, subtraction, multiplication, and division. It's the math you use every day when counting money, measuring ingredients, or splitting a bill with friends. Algebra. Instead of using only numbers, algebra uses symbols like x and y to represent unknown values. It helps us create equations to solve for missing information, like solving a quadratic equation to find the unknown variable x. Geometry. Look around you. Buildings, roads, and even nature follow geometric patterns. Geometry is a branch of mathematics that deals with the study of shapes, sizes, positions, and properties of objects in space. It explores concepts like points, lines, angles, surfaces, and solids, and how they relate to each other. The word geometry comes from the Greek words geo, which means earth, and metron, which means measurement, originally tied to measuring land, and understanding the physical world. Trigonometry. Trigonometry sounds complicated, but it's really about studying triangles and their angles. Its name comes from the Greek words trigonon, which means triangle, and metron, which means measurement. So it's literally about measuring triangles. At its core, trigonometry deals with these 6 key functions, which let you calculate unknown sides or angles if you know some of the others. If you've ever used a map or a compass, you've already used basic trigonometry without realizing it. Next up, we have calculus. Ever wondered how we predict the movement of planets, the speed of a falling object, or even how fast a disease spreads? That's calculus. Without calculus, we wouldn't have physics, engineering, or even computer graphics for video games. Calculus splits into 2 big ideas: derivatives and integral. Derivative, which measures slopes of curves, tells us the rate of change of one quantity with respect to another. If you are driving and your distance traveled is given by s of t, where t is time, then the derivative of distance with respect to time gives us speed. Integration is the reverse process of differentiation. If a car's speed is given by v of t, and we want to find the total distance traveled by the car, we integrate it like this. Next up, we have topology. Imagine you have a rubber band and stretch it into different shapes without cutting it. It's still the same loop, right? While geometry cares about exact shapes, sizes, and measurements, think about rulers and protractors, topology focuses on properties that stay the same even when you bend, twist, or stretch something, as long as you don't tear it or glue new parts together. Key ideas in topology include connectedness, like a circle is connected. 2 separate dots aren't. Then holes, like a sphere that has no holes. A donut, also called a torus, has 1 hole, and a pretzel